So let's go through um, the topic blockchain. It is part of semester 3 for an online learning course MCA from the head. So these are the notes from that. So first we look into what is privacy. It's a state in which one is not observed or disturbed by other people. It's a state of being free from public attention. Okay. So uh, these are like different years or places where the obstruction of privacy as a means of oppression. For example, in 1961, the FBI targets 12 leaders of the Puerto Rican independence movement for surveillance. 1985, of the 33,120 pages of information on 600 Muslim entities in the US by FBI's Operation Wildberg, there have been no convictions. So this is Michael Foucault's panoptation. Here the prisoner is seeing without ever seeing, and that the guards can see everything without ever being seen. So that's how it is designed. Okay. Now we'll learn what is a cyberpunks and crypto anarchists. So privacy is the power to selectively reveal oneself to the world. Cyberpunks and crypto anarchists, they are like librarian groups, libertarian groups concerned with privacy and advocated cryptography as an important tool. So this is like a manifesto. So here the manifesto says like a private matter is something one doesn't want the whole world to know, but a secret matter is something one doesn't want anybody to know. Okay, so that's it about privacy. Now, how money has evolved. So it started with barter, then moved to gold, then moved to metal coins, then moved to paper money. Then now we have plastic cards, now we have electronic money, and now we have cryptocurrency. So this is how it moved. So in barter system, how it was, cash and credit, there's a precise value. Credit cards, it is not secure 15 years ago to use it online. Okay, now then we have first virtual set is the Visa and MasterCard cards which were developed. Then we have Cyber Cash which is implemented set and had digital cash product Cybercoin. Okay, but this company failed due to Y2K issue. So and it went bankrupt. So this is evolution of money explained in little bit detail, like how the set software took over PayPal and how credit card needs approval, things like that. So how this cryptography or this currency, all this came into existence. So in 1983, David Shum came up with the idea of applying cryptography to actual cash. So Shum with Fiat and Nord came up with electronic cash. Okay, so now they peg the value of digital cash to the dollar of a commodity. Okay, so Bitcoin was the first virtual currency. It came with B Money and Nick Szabo with Bit. Okay, so this is just about them and the years when it just occurred. So 2005 is Big Call game with Nick Szabo. So this is David Shaw. Okay, so he's the founder of DigiCash in 1990. Okay, and they use blind signatures public key cryptography, so that allowed users to sign off on transactions without revealing anything about their identity. But this failed due to centralization. Then came hash caches invention, hash cache invention by Adam Black. So it's a partial hash collation based postage scheme. Then, so this is how the coins are minted by expending resources instead of by a central bank. So solved puzzle using a cryptographic hash function. So this was designed as a mechanism to limit email spam. Then came B Money by Wayday. Okay, so to in this the keeping ledger that came in, that kind of a concept came in. 1998. Now, B-Money, it introduced two protocols. So, every participant should maintain an individual database of how much money belongs to each user. Now, last was Big Goal by Nick Szabo. Okay, so it's a creation of money using Hashcash. So it's a way to keep tokens fungible. Okay, now who, what, and when. So who sets David Shum eventually came into DigiCash starting 1981. What do I send? Way they be money, but also it was proposed in the period 1997. Hashcash again. Um and when do I send? That is Santoshi Nakamoto Bitcoin. So this is like showing an advancement of all these inventions. So Bitcoin laws, it's also way coin supply cannot be inflated as well as POW being used by adding blocks and rules in the network. Okay, so now moving on to the next topic, cryptocurrency. So whether central bank is needed. So is it possible to create digital money without centralized authority? So from that came Santoshi Nakamoto. Okay, so he came up with a Bitcoin white paper in 2008. It launched. Okay, so he was the anonymous creator of Bitcoin white paper, and the next. So some more on this. Santoshi Nakamoto is a name used by unknown person or people who develop Bitcoin, authored the Bitcoin white paper, and he's a creator of Bitcoin client. So his name itself has some puzzle in it. Like Santoshi means wisdom and reason, and Nakamoto means so together it means central source. Okay. So until 2010, they were active with the development of Bitcoin. Okay, so so cryptocurrency, it's a digital asset designed to work as a medium of exchange. So they're kind of alternative currency and they use decentralized control as opposed to centralized digital currency and central banking systems. Okay, now so the next coming to history of digital ledger and proof of work. So history of digital ledgering. So we had this ledger concept in counting, right? So it, it's like this Haber and Stonet. They proposed a method for securing timestamping of digital documents. So goal of timestamping is give an approximate idea of when a document came into existence, accurately convey the order of creation of these documents. Okay. So this Father Luca Aquilio, he is referred to as the father of counting and bookkeeping. So this is Luca Aquilio. Okay, so these are the two people I said earlier, Stuart Haber and Scott Stonert. Okay, so they came up with the time stamping of documents. So when the server receives a document, signs the document together with the current time as well as a link or pointer to the previous document, issues a certificate with this information. Uh, so using all these concepts, Bitcoin used these concepts to record the Bitcoin transactions as blocks in the blockchain. So that's how this blockchain came into existence. They use the time stamping of documents that process. Okay. So Moni Naor and Cynthia Dot, they came up with the concept as a way to deter denial of service attacks and other service abuses such as spam on a network by requiring some work from a service requester. So proof of work was first coined, that word proof of work, and formalized as a 1999 paper by Marcus Jacobson and Ari Juels. Okay, So they use this concept to solve. So Bitcoin is generally used to solve cryptographic hashing puzzle by the miners. So the first miner who solves it will get access to the next block. Okay. Now blockchain. So we learned like timestamping of documents is used to create a concept of block in a blockchain, and like a game, the first person who will solve will get access to the next block. Okay. So this is about blockchain technology. So um, this Scott Stornata, they eventually they utilize Satoshi Nakamoto, and he they developed Bitcoin's blockchain infrastructure, and so they started with this blockchain technology revolution. Okay, so blockchain is nothing but a growing list of records called blocks which are linked using cryptography. Okay, so blockchain is resistant to modification of the data. Okay, it's an open distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. So the first block in this chain is called Genesis block. So who is the father of blockchain? As we said earlier, Scott Stornata. So, uh, so they came up with this instead of World Wide Web, it can be something like if we all over they keep using these blockchains, it will be like worldwide ledger, because from timestamping of documents this was created. Um, so this is like a simple way to verify transactions and record them so that other people cannot erase or anyone can see them. So blockchain and what are its key benefits? So blockchain, it provides full visibility to all actors across business ecosystems. So the benefits are it reduces risk of collusion and tampering, removes overhead and cost intermediaries, increases trust through shared process and record keeping, eliminates fraud. Okay, now we have something called decentralized application. That is a concept which is used all over in blockchain. So to understand that representation, this is the first one. First diagram A is centralized, second B is decentralized, and the third one is distributed. So in centralized, all the nodes are connected to each other. It's a single point of failure. If server fails or runs into error, everything will fail. Distributed also, what happens? Each node will have different set of data and same set of software. Okay, they are used when large volume of data is handled by the applications. Okay, so if the controlling node fails, another node will take over as a controlling node. So if any of the node fails, the data from that node is aware, result will be partial. Full failure will not happen. Okay, but what happens in the case of decentralized? It's a peer-to-peer architecture. So all the nodes are like peers of each other. Okay, so one node can become a master by voting or staking and helping coordinating part of the system. So here each central node contains a replicated copy of the same software application database, including same set of data. So in the main benefit is there's no point of failure. So if one node goes down, system will run with all the other nodes. Okay. So that's the concept. Now, what is B2B? P2P e-cash paper. So this is one paper which Santoshi came up with. So Bitcoin. And Santoshi came up with that, and then Bitcoin came into existence. So Bitcoin, it represents a culmination of decades of research in cryptography. So it's a centralized, consists of decentralized peer-to-peer network, public transaction ledger, decentralized mathematical and deterministic currency issuance, and it has transaction verification system. Hmm. So these are like the concepts which are used. Okay. So analysis based on Bitcoin, cryptocurrency uses concepts of cash and cryptography, and blockchain uses ledger and secure stamping of digital documents. Now what is the CDBC and digital rupee? Okay, now CDBC is nothing but central bank digital currency. So some kind of a system they have created, which is used by financial institutions to hold reserves and settle interbank transactions. Okay, so Russia's digital ruble, China's digital yuan, and India's digital rupee are on trial now. 80 countries projects are underway now. Okay, now this is digital rupee. Digital rupee is something like this. So this is like the e-rupee, which is like the central bank digital currency. So it was in for wholesale in this date, and for retail it was in this date. But this will not earn. It's saying this digital rupee for retail to not earn any interest, but can be converted into bank deposits. Okay. See, this is what is these digital bank notes and coins. It's looking something similar to what we have. So it will have like this E mark like that. So okay. Now blockchain history, more on blockchain history and how it has grown. So it started 1991 and then moved to 2010 when in blockchain came, and 2012 again the blockchain it evolved, and more concepts like Ethereum came into being. Then 2014-15 Ethereum further developed and a Genesis block came. And Linux Foundation, they came up with Hyperledger. Then in 2016 a bug was found in that Ethereum. Then 2018 applications have started to use it. So this is like the history. Okay. So first it was blockchain 1, then it evolved to smart contract, which is 2, then it evolved to 3 DApps, and then 4. Okay. So Bitcoin blockchain 2009 it had proof of work, that is blockchain 1. In blockchain 2 that time Ethereum blockchain came, uh, and it got converted to proof of stake system on to 2022, and then blockchain 3 the Cosmos came into. So these are the different blockchain consortium and collaborative projects. Okay, so which are the different countries which are using this crypto regulation? So we have like Canada, USA, Mexico, many different countries, Nigeria, Venezuela, Brazil, Switzerland, Chile, Europe, Lithuania, Russia, China, Japan, South Korea, Australia, India, Kenya, Zimbabwe. So they are all following some kind of regulation for this cryptocurrency. So behind the success of Bitcoin, all these different industries are there. Okay, so I think okay. So uh, just a minute. We'll go to where we stopped. It's 104. So this is like the we go to 104. Just a minute. Okay. So okay. So these are by country the crypto regulations, and this is where the success of Bitcoin is. So this is like the hype cycle for blockchain business, like a graph, and practically how this blockchain is. It's a type of distributed ledger, expanding chronologically, orders list of cryptographically signed irrevocable transaction record shared by all participants in the network. So they were like we learn about the mining process in blockchain. What are the types of blockchain and when to use what type of blockchain? So the first one is called Genesis block. Then you have the block 1 hash. Then you have the block 2 hash and then the block 3 and the block 4. So what does this hashing concept? So it's like if the input is a text string, using any of the hashing algorithm, respective 64 character um, is created. Okay, so which is unique. So in the mining process, this concept of hashing is used. So what they do is they in a blockchain, in the block header, it will combine with the hash and then it will check if take the hash and it will check if the hash is less than target value. If it is yes, then the mining reward is taken and add the block back to the blockchain. If it is no, you add one, increment one more and then create the hash and again the same loop is followed. So this is how it's immutable transactions. There's a concept of immutability in blockchain. So these are the different types of blockchain: Bitcoin, multi-chain, Ripple, and Hyperledger Fabric. So Bitcoin is like more of authentic blockchain, fully decentralized. Anyone in public can join and participate in the blockchain. Now, multi-chain is like partially centralized. Hyperledger Fabric, it's not a true blockchain. It's using centralized, and Ripple is partially centralized. Okay. So when to use what type of blockchain? So do you need to store the state? Then if it is yes, go to the next one. Are there multiple writers? Yes. Can you use an always online TTP? If it is yes, then go back to the are all don't use blockchain if you get yes over here in the third one. But if it's no, then you can use permissionless blockchain. Okay, so these words are like coming from the previous slide. So based on what you get from this, you will choose the type of blockchain over here. Okay, now there are hybrid, public and private. Okay, now so public blockchain, private blockchain, consortium blockchain, and hybrid. So these are the four different types and what, how is the access, users, verification, the incentive, everything is put in this table. Okay. So now what is the difference between Bitcoin and Ethereum, a comparison? Bitcoin is by Satoshi Nakamoto, Ethereum is by Vitalik Buterin and team. Okay, so Bitcoin is a cryptocurrency, whereas Ethereum is a network software. Okay, Bitcoin, the coin symbol is BTC, and Ethereum is ETH. Hmm. And the size, block limitation, everything is mentioned here. So now the next, moving to the next one. Okay, now what are the blockchain consensus algorithms? So a consensus algorithm is a fault-tolerant mechanism that is used in computer and blockchain systems to achieve the necessary agreement among the process on a single data value or on a single state of the network. So some of the examples are Google's page rank, load balancing, smart grids, clock synchronization, and drone control. So the objective consensus algorithm, they are agreement seeking, collaborative, cooperative, egalitarian, inclusive, participatory. Okay, these are the properties, structure, security, and performance. These are the different consensus algorithms. Now, uh, the next topic that we will discuss on is what is the proof of work and what is advantage and disadvantage. So it's a standard consensus algorithm used by Bitcoin Litecoin. Okay, so originally published by Cynthia Tork and Moni Noor in 1993. So participant in this, a participant node is expected to show that the work they have completed and submitted that allows them to obtain the right to add new transactions to the blockchain. So it's a complex mathematical puzzle, and the ability to quickly prove the solution are the key working principles. So each block's hash contains a previous block hash, which increases security and prevents any violation of block. So advantages and disadvantages. Disadvantages: 51% risk, time consuming, useless calculations. But advantages: defense from DOS attacks and mining possibilities. So this is a person who came up with Ethereum, Vitalin Buterin. So in order to secure blockchain, so they need to burn over 1 million worth of electricity and hardware costs. That's what they said. So its energy consumption is you can power an entire country, but US is trying. So these are some of the news things that came. Estimated electrical cost of mining 1 Bitcoin by the country in US dollars it's given. Okay, now the next. So this is energy consumption related to several countries. So if you see here, you can see United States is the lowest. Applications of POW algorithm. Okay, so Bitcoin-based cryptocurrencies such as Litecoin is based on similar model. Proof of X schemes is an umbrella term for systems that replace POW with more useful energy efficient alternatives to. So it's a more different alternative to proof of work. So proof of stake, we are getting into that concept. Okay, so proof of stake consensus states that according to how many coins he or she owns, a person may mine or validate the block of transactions. PP coin was the first cryptocurrency to apply POS to the blockchain. Okay, so this means that the more a miner holds Bitcoin or altcoin, the more mining power he has. Okay, so many blockchains they adopted POW at the beginning and then they transformed to POS gradually. So, so this is like a randomization concept is there. So it uses black coin, it uses randomized predict the next generator. So it's use a formula loops for the lowest hash value in combination with the size of the stake. So these are the pros and cons of proof of stake. So higher speed compared to POW, but it's still vulnerable as many person with ample money to invest may buy an insane number of coins, reducing the system decentralization. So handles accessibility, centralization, and scalability. So this is like the difference between proof of work and proof of stake. Okay, so So they can be proof of stake can be thousand more times cost effective. Okay. Now proof of work and proof of stake. So it's like simply how it is explained. So here in proof of work, the amount of work done by a particular miner determines his possibility of mining a single block or rewarding getting a coin. But here in the proof of stake, the mining capability of a particular miner depends on how many coins she already has. That's the difference between both. Okay, here in the first proof of work, it gets lesser Bitcoin over time, but the 51% attack is ridiculously expensive in the proof of stake method. Now we come into concepts like delegated proof of stake consensus and practical Byzantine fault tolerance consensus. So what is delegated proof of stake? Okay. So active DPoS based blockchain uses vote for witness and delegates by putting the tokens on the candidate's name. Okay. So delegates are chosen to oversee the process and to propose key changes. So this is a delegated proof of stake DPoS. So there's like a witnessee. You can validate more transactions and for the block get rewarded for them. Hmm? The major difference between POS and DPoS is that POS is a direct demographic, whereas DPoS is representative democratic. Higher throughput is there. Okay. Now, examples are stem and bit shares, steam and bit shares. Advantages are these. Then disadvantages are it's more susceptible to centralization as there are small number of witnesses. Now, what is practical Byzantine fault tolerance? Okay, so it aims to provide a realistic replication of the Byzantine state machine that can run even when malicious nodes are functioning in the system. So suppose some malicious nodes are there, how will it function? So aim is that all honest nodes using the majority rule help to find a consensus on the state of the system. So it consists of the following steps: request, pre-prepare, prepare, commit, and reply. Hmm. So it's a replication algorithm to tolerate Byzantine faults. Okay, so Hyperledger Fabric it utilizes this PBFT as its consensus algorithm so that it can handle up to 1 by 3 malicious Byzantine replicates. Okay, so the advantages and the disadvantages are here. Now, what is Ripple protocol consensus algorithm and related topics we'll see. So it has certain concepts in it. So this is how the Ripple consensus works. So Ripple is a consensus algorithm that utilizes collectively trusted subnetworks within the larger networks. They are divided into two types: server for participating consensus process and client for transferring funds. So UNL is an important concept here, a unique node list. It's important to the server while determining whether to put a transaction to the ledger. The server would query the nodes in the UNL. For a node, the ledger will remain correct if the percentage of faulty nodes is UNL is less than 20%. So replica nominates itself as a ledger when a client executes a command on a given replica. Okay. Now we have something called Paxos. So separate instance of basics Paxos for each entry in the log. Okay. So it's just like client sends server command to server. Server uses Paxos to choose command as value for a log entry. So waits for previous log entries and server returns result from state machine to the client. So Raft. Moving to Raft. Raft is a model of consensus which is guided by a ledger. A replicated log is maintained by the leader through all of the nodes using the Raft cluster. So the advantages are these, and it's like a single ledger protocol. So the disadvantage is it can choke the system. Okay, so um, uh, so what is this POET concept? It was invented during 2016 by Intel. So advantages of it's a ready-made high-tech tool to solve the computing problem of random ledger selection. And these are the advantages. Now moving to the next topic. So we have proof of burn, proof of importance, proof of capacity, deposit, proof of activity, proof of authority, proof of retrievability, and proof of luck. Zero knowledge proof. So proof of burn. Okay, the coin burning method decreases the supply of market and induces economic scarcity, leading to a possible rise in its value. Hmm? Slim Code implemented this approach in 2014 but has recently been discontinued. So these are the advantages and disadvantages. Proof of burn and proof of importance. So importance is like the nodes that are eligible to add a block to the blockchain through a process called harvesting. So we will harvest a block, collect transaction fees associated with the block. Okay, now proof of capacity. Participant vote on new blocks weighed by the capacity to allocate a non-trivial amount of disk space. Proof of capacity examples are permacoin and spacemint. So it's a two-step process involving plotting and mining in the proof of capacity protocol. Now this is like the advantage, disadvantage. Proof of deposit, it's like miners lock a certain number of coins which they cannot spend for duration of their mining. Okay, so to combine benefits of proof of work and proof of stake, proof of activity was proposed. Okay, now proof of authority, it leverages identity instead of coins. So Cohen and Ringby, the two Ethereum testnets, they use proof of activity as consensus mechanism. Even Microsoft Azure is another example where proof of activity is being implemented. Then proof of retrievability. It offers standard functions for issuing, verifying, file proofing on a remote host. Proof of luck we have. The luckiest block is considered as the next block in the chain by the ledger. So these are like advantages. Now here it's like with an example, they're saying something about Alice and Bob, and this is like a comparison table between all the topics which we just discussed right now. So coming to the next different attacks, proof of X, nothing at state attack and grinding attack and long range attack. So looking at one of them, grinding attack is a miner recreates a block multiple times until it is likely that the miner can create a second block shortly afterwards. Okay, now the history generation and initiatives. I think this was already discussed. So just skipping this. Yeah, all this was already discussed. So let's see the next topic. Even blockchain consensus algorithm is discussed. This also we discussed. Proof of work, proof of X we have discussed. Okay. DPoS, no, that topic we have discussed. Let's look into the next one. Yeah, the other consensus RPCA that we have discussed. Yeah, all the different proofs we just discussed. Okay, now let's move into the next one, module 4, cryptographic primitives. So cryptography is used in each one of them. Bitcoin is the most well-known blockchain. Okay, so how we can bind a person's identity with a Bitcoin account? So solution is each user given creates an identity for himself or herself. Identity consists of 256-bit random string. So, so Bitcoin uses this elliptical curve group. Okay. So a transform version of the public key is the Bitcoin's address. So anyone can send coins to an address. To spend the coins, you require the private key corresponding to that address. So if the private key is lost, all the coins with the corresponding public key are lost. Okay. So now, what are cryptographic hash function? I think you know what is a hash function. It's a mathematical function. It can have these three properties. So to convert that input string into an output with this many bit size. Okay. So there is Bitcoin uses SHA-256 hash function. So it uses Merkle-Demirag transform to turn a fixed length into 512. Input is padded so that the length is a multiple of 512. So uh, cryptographically secure hash functions, they have three properties: collision resistance, hiding, puzzle friendliness. So hash function, general hash function, the syntax is given. What is a hash pointer? It's a pointer to where data is stored together with a cryptographic hash of the value of data. Linked list uses hash pointers. It's called the blockchain. Second cryptographic primitive is digital signature. So digital signature scheme consists of following three algorithms. So I think this is self-explanatory. Generate keys method, it takes a key size, generates a key pair. The secret key SK is kept privately and used to sign messages. PK is a public verification key that you can give everybody. Anyone with this key can verify a signature. So SIG is there and is valid is there. So these are like three different methods. Okay. So sign method, this is second method. It will use a message and a secret key. Now put a signature for the message. This one it will verify the message signature and public key as input. So if the key is valid, it will check. Okay, and signature is valid for the public key. Otherwise it's false. Uh, so Bitcoin uses ECDSA. I think it's elliptical curve, that one. Okay, so it's done by this digital signature. Hmm? So they are like analogous to paper signatures in the physical world. Digital signatures, they not only authorize spending but also provide undeniability and integrity. Okay. Now the MD starting hash functions are discussed here. Okay. So in MD case, the ephemeral secret K should not be reused. So reuse of K allows recovery. If K is reused, we can recover the private key, no? So for that, use a deterministic method to generate K. Hmm. So that's how then Bitcoin wallets and Android bug was found. Okay. So that's how it was found, because the Java secure random library had a bug. That's why it produced colliding K values, and easily you can get the private key, right? So that is what users' wallets and all will come into big. Means if you get the key, anyone's wallet you can open. So it's just what had happened was discussed. Okay, and so ECC for address digital signature, cryptographic hash functions or proof of digital signatures, and hash functions also provide tamper proofing and public verifiability. Hmm. Now, different type of signature schemes are group signatures, ring signatures, and multi-signatures. Commitment scheme allows a party to commit to a value without revealing it immediately. Example, use lottery. Lottery. So, um,
So how is this commitment used in stateless blockchain, replacing the blockchain storage with commitments? Problem with Bitcoin is loss of privacy due to link traceability. Okay, uh, so this zero coin solved it by using accumulator. So one way membership function to test if a candidate is a member of a set without revealing individual members of the set. So zero argument it convinces a skeptical verifier to accept the validity of some statement. Hmm? So this is like the example to understand this. Okay. Now we will move to the next topic. What is a bit? How is a Bitcoin block structure made? We have something called hash pointer. So the data will be there. It will draw hash pointers like this. So it's like build data structures with hash pointers. So linked list with hash pointers. That is the equivalent to a blockchain. Uh, yeah. Detecting tampering using tamper evident log. So it's using this Merkle tree hashing algorithm, right? So how this is done? That's what is shown in this diagram. Hmm? So this is like uh, the how much efficient it is log in times. So now hash pointers they can in any pointer based data structure that has no cycles. Okay. Now we have something called a double spend problem that we are going to discuss here. So this is like a in simple cryptocurrencies you will use public key as addresses. Okay, signed to authorize transfer to new address. So that's what. So new coins belongs to me. Okay. Now coin or coins owner can spend it. Okay. Now recipient pass it again to another person. So now what happens is same coin is spent by the second person. That's called double spending attack. This is a main design challenge in digital currency. Hmm. So double spends must be prevented. So talk to the issuer. Okay. So that's how the Scrooge coin came into picture. Okay. So create coins, it will create new coins. Okay. So now that's the Scrooge coin. Okay. Yeah. So pay coins, it will consume and destroy some coins and create new coins of the same total coin at in total value. Okay, this is like immutable coins. Scrooge publishes a history of all the transactions. History is maintained, but you will not reuse the same coin. So, what if the Scrooge is malicious? Uh, so that's like a thought. Now, Bitcoin's approach is using global ledger hmm, in distributed P2P network, how to achieve consistency. Example of public ledger from banking sectors. Okay. So this, if you look at this diagram itself, it is like explanatory. Alice is giving Bob bag 50 that way. So and each time a transaction is made, you are like writing down in the ledger. Okay. So but here it should be 50, not 80, right? Yeah, because what Alice gave to Bob, only that she is giving, not 80. Hmm? So part to decentralization. Hmm? P2P network. So that's what we are going to. Ad hoc protocol runs on TCP port 833. So this is like Bitcoin mining Bitcoin in 6 easy steps. We will look into this. So we know it's a hash tree Merkle tree. So So it's like, see, these are the different steps: minus, block puzzle, proof of work. A new block is added to the existing blockchain. That's how the process starts from here and comes back here. Okay. So uh, this is like the in steps. Join the network. Miners will assemble them into new blocks. On success, the broadcast to new block. Listen for new blocks. Find the nouns to make your block valid. Hope everybody accepts your new block. Okay. So now this is like the Bitcoin transactions. So each time it's checked whether it's valid or not. Um, so Coinbase ledger, not Bitcoin. Okay, Bitcoin blocks. Single unit of work for one by bundle transactions together. So single unit of work for miners. Faster to verify history. See, this is just the working principle. Here we are discussing the consensus algorithm, but in a more simpler way. Hmm? Okay, so there's a cost function which prevent DOS motivated attack or computation attacks. So the so this is like the proof of work. Okay, so hash it's using SHA-256, so it's very difficult to just break it or find any sort of attack on it. Okay, so this is like some websites wherein you can refer and understand more about this Bitcoin. Okay, now there are two kinds of forks, I mean Bitcoin forks, soft forks and hard forks. So what are these forks? Basically, they are like some kind of tools which will help you for these Bitcoin transactions. So how these grown over the time, Bitcoin forks that is being shown. Okay, and the comparison between different forked Bitcoins. Um, so in this we have something called altcoin, but it's not a real cryptocurrency. But there's a website CoinGen which is using to automate the process of minting any altcoin. It's referred to as Bitcoin alternative, at least to some extent, but altcoins hope to either replace or improve upon at least one Bitcoin component. Fiat currency is by a country's government instead of a physical commodity. Okay, so it's printed or minted by the central India. Fiat currency example is Indian rupee, US dollar, euro, yuan, yen. Now some references here. Okay, now what are the limitations and improvements to be made? So these are some limitations or improvements in Bitcoin compared to Visa or PayPal. Okay, so what are some of the difficulty or the time taken behind the scenes? That is shown. Mining difficulty, mining pseudocode, CPU mining, all those things are discussed in these slides. So for time to find a block is this much, see, 10 minutes. So now next is it's a discussion on cryptography, public key, private key address and comparison of keys. Private key uses ECDSA, which is corresponding to create a corresponding public key. So here you have to create public and private key on your own. Download a program that randomly creates and which generates private keys based on a seed code. So this is just how the process will work. Private key using ECDSA public key, and then it's hashed, and then base check is there, Bitcoin address you will get. Okay, so using that only we use as an address to store for the Bitcoin transaction. Now, the different kinds of wallets that are available. Okay, for this Bitcoin transaction are there's something called hot storage and cold storage. So hot storage has all these things and cold storage has this. Then they have private key and restoration method. So cryptocurrency wallet is a digital wallet that you can use to store and receive various cryptocurrencies. So cold storage is somewhat similar to your savings bank account. Okay. And hot storage is wallets that you can carry around in your pocket. That's the only difference. Um, so the different types of wallets and all are discussed here and the pros and cons. When we have something called paper wallet, it's an offline cold storage method of saving cryptocurrency. And importance of why we have to use private keys and restoration methods so that it's more secure, and to avoid all kinds of risks. Okay, now moving on to the next topic. Bitcoin is like bootstrapped, okay, meaning it's like using something which is already there, no? The technology is there. So how big the Bitcoin network is? It has went up to 1 million IP address per month. So this is what the strange cost of it is there. Hmm? So there's something called unspent transaction output. Everything else can be stored on disk. Okay. Now this is like more on mining infrastructure. Okay. Block reward and transaction fees. Okay, what is a key security assumption made by the hash power follow the protocol? The assumption, okay, there's a finite supply of bitcoins, but it runs out in 2040. So no new bitcoins will be there unless rules change. So information about a transaction is information about a Bitcoin transaction. So there's a transaction fee for it. So if you don't pay the consensus fee, your transaction will take longer to be recorded. Okay. So this is the mining economics explained in this diagram. It's finally we come up with a Bitcoin improvement proposal. They are like designed the documents, okay, describing new feature for the Bitcoin. So these are like the Bitcoin improvement processor. What are the processes involved? Okay, in the proposal. Okay, there's a Bitcoin scripting language. Um, so these are the script instructions. It's in. So there are 256 opcodes total, and these are some of the pointers followed in that. Okay, so these are some of the symbols and values and what will happen. Okay, these are the opcodes and what will happen in that language. Okay, coming to Bitcoin transaction, this is a transaction. Input address also as script. So using the knowledge we learned just now, like there will be public key and a hash and all that is added together. But what is a transaction? So this is like the input and what happens in the output. So this is like what happens here in the transaction. See, like a hash value is there. You can see, blockchain has something called Explorer. Let's see whether, okay. So what are the applications of these? We learned that there is a Bitcoin script. So what are the applications for this? It's like smart contract is made in that, okay? How does a Bitcoin transaction actually work?